Hi everyone, my name is Hongyang Yu, and I'm the second author of this work from Oracle Health and AI. This project is in a joint collaboration between Oracle Health and AI and the University of Queensland. Today I present our work, OraPO, Oracle Educated Reinforcement Learning for Data-Efficient and Factual Radiology Report Generation. Radiology report generation aims to convert medical images into clinical useful narratives. This is important because radiologists face enormous workloads nowadays, and reporting delays can directly affect patient care. However, current vision language models still struggle with clinical factuality. A report might sound fluent, but can still contain missed findings, contradictory statements, or clinically incorrect conclusions. Most existing approaches rely heavily on supervised fine-tuning with very large data sets. More recently, GRPO-style reinforcement learning has shown promise, but it depends on verifiable rewards. The problem is that in radiology, rewards are extremely sparse. Earlier during training, models often generate poor reports that receive zero reward because the model essentially has no radiology knowledge. Um, this creates what we call the all zero reward group problem, where GRPO essentially receives no meaningful learning signal. Our key insight is zero reward samples are not useless. They are valuable negative samples. So instead of discarding failed generations, OraPO reuses them through a DPO-style preference learning objective. At a high level, standard GRPO works well when at least some generations obtain non-zero rewards, but when all generations fail, policy gradients become ineffective. OraPO adaptively switches behavior for the informative groups, we use normal GRPO updates. For all zero groups, we convert failed explorations or rollouts into preference pairs against the Oracle ground truth report. This effectively transforms failed explorations into supervised preference learning. So Oracle really combines exploration from reinforcement learning and stability from DPO in a unified framework. You can think of it as an Oracle guided recovery mechanism for sparse reward reinforcement learning. Another important contribution is our fact-based reward design, which provides denser and more clinical interpretable supervision. Now let's look at the main results. On the CheckSpert Plus benchmark, Oracle achieves the state-of-the-art recall and F1 scores, while using less than 1% of the training data reused by prior methods. In radiology, recall is especially important because missing abnormalities is clinically dangerous. Compared with models trained on hundreds of thousands or even millions of samples, OraPO achieves an F1 score of 0.341 and recall almost 84% using only 1,000 training samples. So the key takeaway is we achieve strong clinical effectiveness with dramatically improved data efficiency. We also compared against much larger language models. Even with only a 3 billion parameter backbone, which is the Queen 2.5 vision language model we're using, OraPO outperforms substantially larger fine-tuned models in F1 and recall. So this suggests that better reinforcement learning signals and better utilization of failures can matter more than simply scaling up model size or training data volume. In other words, smarter optimizations can substitute for brute force scaling. We further validate OraPO on the independent Mimic 6 benchmark. Again, OraPO generalizes strongly across datasets and achieves the best record and competitive F1 despite extremely limited training data. On the bottom right plots, we analyze the reinforcement learning dynamics. Valina GRPO suffers from persistently high zero reward ratios. OraPO rapidly reduces zero reward groups during training because failed generations are converted into informative preference supervision. So this actually leads to faster convergence, more stable optimization, and better downstream clinical performance. So empirically, Oracle directly mitigates the sparse reward failure mode of GRPO. So to summarize, finally, OraPO is a reinforcement learning framework for radiology report generation that reuses failed rollouts through Oracle guided DPO, mitigates sparse and zero reward issues, achieves strong factual clinical performance, and dramatically improves data efficiency. More broadly, we believe that this idea can be extended beyond radiology to other sparse signal domains where reliable rewards are difficult to obtain. Thank you very much, and thanks for your attention.